All right, now we are going to talk about inverse of a function. Inverse of a function, right? So let's see. Inverse. Inverse functions. All right. There are many um, different possible explanation, and there's definition you can certainly look into. Um, if you think of, but this is what I want you to understand. If you think of a function as a box, right? X goes in and f of x comes out, and we call this input value, and we call this as output value, right? Now, inverse function goes backward, So this goes in, this comes out. So in a way, it's like a reverse function, right? Reverse function. Example. Let's say function is um, 2x, right? So f is fx, the function of x defined like this. How would you explain this? X goes in. What happened to that x? Whatever goes in will be multiplied by 2 and it'll come out, right? So, you know, let's say input value x equal 10, what's going to be output? Output value is going to be f of 10 equal, if 10 goes in, 2 times of 10 is going to be 20. So input value is 10, output value is going to be 20. Now, multiplied 2 times and it produced the output. Now, what would you say the reverse process of multiplying by 2? Right? Because like I explained in here, inverse function is going reverse, going backward. So what would be the reverse process of multiplying by 2? The reverse process of multiplying by 2 is going to be, that's right, divide by 2. So inverse of fx, which is equal to 2x, is going to be f inverse x, which is going to be 1/2 times x, or x divided by 2. Same thing, right? That's inverse function. And you can see this funny notation right there, right? See, f to the minus 1 power, that's a notation for inverse function. So inverse function, they say f of minus 1, f to the minus 1. That's a notation for inverse function. So, but you get the idea, right? If a function is multiplied by 2, then inverse function is going to be reverse way. So it'll be divide by 2, right? If a function is adding 1, reverse of adding 1 would be what? Subtracting 1, right? So That's inverse function. So reverse process. I mean, the name says it all. Inverse, right? The reverse process of certain function is going to be what we call the inverse function. Now, let's talk about domain and range. So, domain of f, a function, is same thing as range of f inverse. And also range of f is same thing as domain of f inverse. Oh, don't like that line. Okay. So domain of a certain function is same thing as range of inverse of that function, and range of a certain function is domain of the inverse of that function, right? So domain and range of function is switched for inverse of a function. So if we actually apply this idea, we can go one more step like this. F inverse of f of x is x, where x is in the domain of f, and f of f inverse of x is also x, where x is in the domain of f inverse. Right. Okay, so to show that if we do something like this ends up getting x, prove that the f and f inverse are inverse to each other, right? And it proved that fx, the function, and inverse of that function, if you put it in a composite function format, it becomes x. It doesn't matter which one that you apply first. You apply f of x in as input of fx, or if you use fx as input of f inverse of x, the result should be always dx. So we can apply this and use it as an example. Example says, verify that fx which is x cubed is inverse. Well, no, not this way. Let's say verify that fx and f inverse, which is cube root of square x, are inverse to each other. Right? We need to verify that this and this are inverse to each other. Then try f inverse of f of x. If this becomes x, then we are verifying that they are inverse to each other. So how do we find this? Well, this would be f inverse of fx is what? X to the cube, like that. Then, instead of writing f of x, I'm just writing this x to the cube. Then what would be f inverse? That would be cube root of whatever inside x to the cube. Now what's cube root? Cube root is same thing as 1/3 power. These two cancel out. It becomes x. Right? So we prove this is the case. We can also show that f of f inverse of x. And let's see if this becomes x as well. So f of, what's f inverse of x is cube root of x. But what's f of x? F of x is x to the cube, so whatever that we have, which is cube root of x to the cube. So what's cube root of x? That's x to the 1/3 power to the cube. So they cancel out, becomes x. Now, why is it canceling out? Because we are multiplying this and this. Because we have exponent over exponent, then you're supposed to cancel. Right? You're supposed to cancel. So that's how we get x. So we conclude fx and f inverse of x are inverse to each other. Okay. Now let's try a similar but slightly different example. Verify that the inverse of fx, which is 1 over x minus 1, is inverse of f of x, which is 1 over x plus 1. For what value of x is f inverse of f of x equal x. And for what value of x is f of f inverse of x equal x. All right. So we need to show that this and this are inverse to each other. And we also need to verify, we also need to figure out for what value this is possible, right? For what value this is possible and for what value this is possible. All right. So let's try this first. So f inverse of f of x equal, what's our f of x? Our f of x is right here. So f inverse of, instead of writing f of x, I'm going to write this whole thing, 1 over x minus 1. Okay, now we're going to apply this, right? Because instead of writing x, I'm going to write this. So this becomes 1 over what used to be x. Now I'm going to put this whole thing, 1 over x minus 1 plus 1. Okay, so how do I simplify this? Well, we can look at this as 1 over 1. Then you multiply these two together, put it in the bottom. You multiply these top together and put it on the top. So if you multiply 1 and 1, this is over 1. So I'm not going to bother to write over 1. So 1 times x minus 1 is just going to be x minus 1. And then we have plus 1. So this whole thing become this. And this one is this, right? If I give you a side note for this, if I have a over b, c over d form, then it's going to be b times c, a times d, right? That's how I did it. Now, since we have only 1 here, I'm looking at this 1 as 1 over 1, put it in this format, and then change that to like this, right? A, B, C goes under, AD goes on the top, right? 1 times x minus 1 would be AD, which is just x minus 1. Anyway, so what happened? Minus plus cancels out. This becomes x. So we verify that these two are inverse to each other. But we need to also figure out for what value of x this is the case. Why would they ask this question? What do you mean by for what value? They're asking, is there any x value that might give us a problem? That's what they're asking, right? For what value of x? So, that's right. You can see right here, the problem point right there. We don't want the denominator goes to 0. At any part, we don't want the denominator goes to 0. So we cannot afford to have x as, we cannot afford to have x cannot be equal to 1, right? X cannot be equal to 1. Because if x equal 1, we cannot get to here. It'll blow up right about here, right? Or right about here, even. So they say for what value? Any value, but x cannot be equal to 1. That's the answer. All right, let's do the second part. Second part is saying f of f inverse of x. So f of, what's f inverse? F inverse is this 1 over x plus 1. So it would be 1 over x plus 1, like this. What's our f of x? Our f of x is this 1 over x minus 1. So instead of writing x for f of x, we rewrite f of x here. F of x was 1 over x minus 1. Now, look at what we have in the position of input value. We have this whole thing, which means this position right here, we're going to write this whole thing. So it'll be 1 over x plus 1 minus 1, like this. So, simplify this. 1, this plus 1 minus 1 cancels out. 1 over x. This is what? Again, same deal. Looking at this 1 as 1 over 1. 1 times 1 over 1 times x, which is just x. But we need to also figure out for what value, what x value that we do not want. We don't want x to be equal to 0. Why not? It'll blow up here. It'll blow up here. It'll blow up here. We cannot get to this part if x equal 1. I mean 0. So we have to make sure that x cannot be equal to 0. All right.